Hello students, today we will be solving the IB Math A HL November 2024 paper 1 question number 12. You will be getting the other solved questions of this paper and of the other papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math A HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start solving question number 12. The maximum mark is 20. Consider the equation z to the power of 4 equal to 16 where z is a complex number. The equation has 4 roots z1, z2, z3 and z4 where zi is r cos theta I plus I sin theta I, r is greater than 0 and theta 1 is greater than or equal to 0, theta 2 is greater than theta 1, theta 3 is greater than theta 2, theta 4 is greater than theta 3 and theta 4 is less than 2 pi. So part A's question is find z1, z2, z3 and z4. It contains 6 marks. Okay, so z to the power of 4 equal to 16i. Okay, so therefore z to the power of 4, the modulus of z to the power of 4 is equal to, the magnitude is equal to 16i is what? 0 plus 16i. Okay, you do not have to write this step definitely. I am explaining, so I am writing this step. So 0 square plus 16 square, square root of this will be equal to 16. Okay. And what is the argument? Argument, if you are confused with the argument, you can just draw the Argand diagram. This is the real axis and this one is the imaginary axis. Suppose we have to plot the complex number I. This is 1, 2, 3 and all. Okay, this is 1, this is 2, this is 3, this is negative 1, this is negative 2. So if we have to plot this complex number I, then where will we be plotting? It is a purely imaginary number, so it will be plotted over here. Okay, if it is 3i instead of I, then where should we be plotting the point? We will be plotting the point over here. Okay, so now in this case, it is not I or 3i, it is 16i. So where should it be plotted? It will be plotted somewhere. It is not over here, it will be up somewhere over here maybe. But it will be on the imaginary axis. So what is the argument? What is the angle? Argument means the angle. The angle will be starting from this positive side of the real axis, and in order to reach the imaginary axis, we are covering an angle of pi over 2. Okay, because many students get confused. Like they have the habit of taking if z equal to a plus bi, then they will be doing for the argument tan of argument of z will be equal to b over a. Yes, and it is definitely correct. I am not saying that it is not correct. But if you use this same formula for this case, you will be having b will be equal to 16 and a will be equal to 0, and you cannot have a 0 in the denominator. This is where the confusion arises. How to get the argument, because next they will be taking the tan inverse to get the argument. So as soon as they see that there is a 0 in the denominator, they stop. They cannot find the argument. You come to the Argand diagram. if you plot the number on the Argand diagram, you will be knowing what is the angle. Okay, so argument of z to the power of 4 is theta over 2. Sorry, pi over 2 rather. So I can write z to the power of 4 as 16 cis pi over 2 or 16 e to the power of I pi over 2. Okay. Now I will be using the de Moivre's theorem because I have to get the values of z. So I'll be writing therefore z1 will be equal to 16 to the power of 1 over 4 and e to the power of I pi over 2 to the power of 1 over 4. Okay. So z1 is 16 is what? 2 to the power of 4 whole raised to the power of 1 over 4, which is 2. And this is e to the power of I pi over 8. It follows the laws of indices. It is exactly following the same law of indices that you have. E to the power of m whole raised to the power of n is equal to a raised to the power of m times n. Okay. So this in cis form, if you write the z to the power of 4 in cis form, it will be cis pi over 2 times 1 over 4. That is the de Moivre's theorem. Okay. I have written this in the polar form as well as in the argument form, the z to the power of 4. So when I am taking the fourth root of both the sides, taking the fourth root is equivalent to raising the number to the power of 1 over 4. So that is what I have done. I have raised the z to the power of 4 to the power of 1 over 4 to get z1, the first root, and this is equal to 2 times e to the power of I pi over 8. And they have asked us to give the roots in this form, z I r cos theta I plus I sin theta I. So I will be writing, therefore, z1 is equal to 2 cos pi over 8 plus I sin pi over 8. Okay, this is the first root. Okay, so then what will be the second root? Now, if you plot the points, the roots, the 4 roots on the Argand diagram, you should be knowing that the angle between any 2 consecutive roots will be the same. And the total angle around this origin is 2 pi. So, and there are 4 roots. So, this 2 pi angle will be divided uniformly between these 4 roots. So, 2 pi over 4 will be the factor that will be, or will be the angle that will be added to one root to get to the next root, because this will be the angle which will be between the any 2 consecutive roots. Okay. So, angle to be added is equal to 2 pi over, there are 4 roots, so 2 pi over 4. Always the numerator will be 2 pi because the total angle around any point over here, it is the origin, is 2 pi. It is getting divided by 4 because there are 4 roots. If it was z cube, then the denominator would have been 3. Okay, but the numerator is always 2 pi. So 2 pi over 4, which is equal to pi over 2. So therefore, z2 should be equal to the modulus, the magnitude has to be the same. The angle will be changing. I'll be adding pi over 2 to pi over 8. So it is cos pi over 8 plus pi over 2 plus I sin pi over 8 plus pi over 2. Okay. So this is 2 cos. The LCM will be 8, of course. And this can be written as 4 pi over 8. This pi over 2 can be written as 4 pi over 8 plus pi over 8 will be giving us 5 pi over 8 plus I sine 5 pi over 8. Z3. Now we know what angle to be added. So now the current angle is 5 pi over 8. So I have to again add pi over 2. Because the angle between Z2 and Z3 will be pi over 2. The angle between Z1 and Z2 is pi over 2. Therefore, I have added pi over 2 to pi over 8 to get to Z2. And now the angle between Z2 and Z3 will again be pi over 2. So, I'll be adding 5 pi over 8 and pi over 2 to get the argument of Z3. Okay. So, 2 cos 5 pi over 8 plus pi over 2 plus I sine 5 pi over 8 plus pi over 2. And pi over 2 is 4 pi over 8. So 5 plus 4 is 9. Okay, so 2 cos 9 pi over 8 plus I sine 9 pi over 8. And now, since 9 pi over 8 is more than pi, some students may say that, okay, the argument is always, it is between negative pi and positive pi. So, how are you going to the third quadrant? 9 pi over 8 is an angle from the third quadrant. It is more than pi. So, how are you going to the third quadrant and writing the angle as a positive angle? Because the third and the fourth quadrants are expressed as negative angles. It is true. But over here you see the question, the angles are between 0 and 2 pi. So, all the angles have to be expressed as positive angles. Okay. Therefore, I have written 9 pi over 8. And also I am writing the fourth root also I will be writing it with the positive angle. And then it is cos 9 pi over 8 plus pi over 2 plus I sine 9 pi over 8 plus pi over 2 is equal to cos. Now, pi over 8 is 4 pi, pi over 2 is 4 pi over 8 and 9 plus 4 is 13. So, it is cos 13 pi over 8 plus I sine 13 pi over 8. Okay. So, these are the four roots. Z1, Z2, Z3 and Z4. The roots Z1, Z2, Z3 and Z4 form a geometric sequence. So, part B's question is find the common ratio of the sequence expressing your answer in Cartesian form. Okay, so fine. Let us take the first two. We can take any two consecutive roots. And I am writing the first root in Euler's form. This one is the first root, Z1 equal to 2 cos pi over 8 plus I sin pi over 8. So, this will be 2 e to the power of I pi over 8. Okay. Whenever it is the division or multiplication, I prefer the Euler's form or the cis form. So, and you'll be seeing why. And Z2 is equal to 2 e to the power of Z2 is this. 2 cos 5 pi over 8 plus I sin 5 pi over 8. So it is 2 e to the power of I 5 pi over 8. Okay. Now we will be finding the common ratio. Therefore, common ratio equal to Z2 over Z1 equal to 2 e to the power of I 5 pi over 8 divided by 2 e to the power of I pi over 8, and the 2's will be cancelling, and it will be e to the power of I 5 pi over 8 minus pi over 8. Okay. It will be e to the power of I 5 pi over 8 minus I pi over 8. So I have taken out this I, the common factor, which is equal to 4 pi over 8 e to the power of I 4 pi over 8 equal to e to the power of I pi over 2. So therefore, the common ratio is equal to, the modulus is 1, no doubt, cos pi over 2 plus I sin pi over 2. Cos pi over 2 is 0, sin pi over 2 is 1. So it is 1I, or basically it is I. Okay. So this is the answer for the Sapat B. Okay. So these are the 4 answers. These are the 4 answers for the Sapat E. The roots Z1, Z2, Z3 and Z4 are represented by the points A, B, C and D respectively on the Argand diagram. Sapat C's question is plot the points A, B, C and D on an Argand diagram containing 3 marks. Okay. So this is the Argand diagram that had to be drawn. See, I have drawn a circle of radius 2 units. Why? Because the modulus is 2. Okay. Therefore, if you draw a circle, this is not required. But if you draw a circle, then you can ensure that the modulus, the distance between the origin and the circumference where you will be plotting the roots, will be the same. Okay. Otherwise, the OA may not be equal to OB, may not be equal to OC. They have to be the same because the modulus is the same. So best way is to draw a circle of the modulus. So since the modulus is 2, I have drawn a circle of 2 units, and now you plot the points on the circumference of the circle. The first root is pi over 8. So pi is what? 180. 180 degree divided by 8. It is 22.5 degrees. Okay. So you will not be having a protractor. Definitely you have to draw a rough 22.5 degrees. This may be 22.5 degrees. This may be 30 degrees. I do not know. But I have taken this to be pi over 8. And then the angle between the two roots is 90 degrees. So I have just drawn a perpendicular to this OA line to get the second root. Okay. And then if you extend that OA line on this side, on the other side, you will be getting the point C on the circumference. And similarly, if you extend the BO line, you will be reaching this point D, because the angle between the two roots, the consecutive two roots, is 90 degree. Okay. So this is the Argand diagram. The equation V to the power of 4 is equal to A plus BI, where V is a complex number and A and B are real numbers. And this equation has roots: the complex conjugate of Z1, complex conjugate of Z2, complex conjugate of Z3 and complex conjugate of Z4. Subpart D is saying determine the value of A and the value of B. This is also carrying 3 marks. Okay. So Now, before I solve this question, I just want to show you another equation, and that will be telling you why I am using this this logic. How can I use this logic? Okay, so if there is this equation x cube minus 2x square minus x equal to negative 2, you have this equation. And if I say the roots of this equation are negative 1, 1 and 2. Okay, the roots are in fact these, because if you can see, if you multiply x minus 1, x plus 1 and x minus 2 and equate it to 0, and you take the negative to this side, because negative 1 times 1 will be negative 1 times negative 2 will be positive 2, and if you take the 2 to the other side of the equal to sign, then it becomes negative 2. So practically what I have done is I have expanded and I have got this equation. So the roots of this equation are definitely negative 1, 1 and 2. Okay, so now if I have to verify, I can take any of them. If I take negative 1, negative 1 whole cube is negative 1. Negative 1 square is positive 1 times by negative 2 is negative 2. And negative of negative 1 is positive 1. So this is negative 2. Okay. Similarly, if I take 1, then 1 cube is 1. Next minus 2 and minus 1, again negative 2. And if I take 2, even then you will be seeing 2 cube is 8 and 2 square is 4 times 2 is 8 and minus 2, again negative 2. Okay, so it doesn't matter which root you are taking, the value of this expression will be equal to negative 2. Clear? So now v to the power of 4 equal to a plus bi. Okay, so I can take any of these 4 roots. Of course, I have to take the complex conjugate, but I can take the complex conjugate of any of these 4 roots. I do not have to multiply the complex conjugates of all the 4 roots. I can take the complex conjugate of any of these 4 roots. Let me take the complex conjugate of this z1. Okay, because z1 star is also a root of this equation. Okay, so therefore, this is part D. I am continuing. I don't think I'll be getting sufficient space. So I have shown you the logic over here. Let me do the working of part D over here. Okay, I'm writing the equation once more. V to the power of 4 equal to a plus bi. Okay, now since z1 star is a root, is a solution of this equation, and what is z1 star? It is 2 cis negative pi over 8. Okay, I'm writing this as 2 cos pi over 8 minus I sine pi over 8. Okay, or I can write this as plus and minus pi over 8 and minus pi over 8. Okay, this is a solution. And again, I like this Euler's form, so let me write this in Euler's form also. It is negative I pi over 8. So v to the power of 4, in place of v, I am substituting z1 star. So therefore, since z1 star is a root, therefore z1 star to the power of 4 should be equal to a plus bi. I have shown you that you can take any root, any of the 4 roots, and that will be satisfying this equation. So I am taking z1 star. And what is z1 star to the power of 4? This is 2 e to the power of negative I pi over 8 raised to the power of 4 is equal to a plus bi. Okay. So 2 to the power of 4 is 16 and e to the power of negative I pi over 8 times 4. Okay. So this is equal to a plus bi, or 16 e to the power of negative I pi over 2 equal to 16, sorry, a plus bi, and 16 now I am writing it's in polar form. So it is cos negative pi over 2 plus I sine negative pi over 2. Okay, equal to a plus bi. And cos negative pi over 2 is cos pi over 2 is 0. So this is 16, 0, and sine negative pi over 2 is negative 1. So this is 0 minus I equal to a plus bi, and 16 times 0 is 0, and so this is negative 16i equal to, or I can write 0 minus negative 16i equal to a plus bi. Therefore, a is equal to 0 and b is equal to 16, negative 16. Okay. Now, the midpoint of AB is A prime, midpoint of BC is B prime, midpoint of CD is C prime, and midpoint of DA is D prime. Consider the equation W to the power of P equal to 2 to the power of Q, where W is a complex number and PQ is our positive integers. 4 of the roots of W to the power of P equal to 2 to the power of Q are represented by the points A prime, B prime, C prime, and D prime. Subpart E's question is find the least possible value of P. P and Q are positive integers and the corresponding value of Q, containing 5 marks. Let me draw the Argand diagram and draw these A prime, B prime, C prime, and D prime. First of all, now this is the Argand diagram that I have drawn. First of all, I have drawn a circle with radius 2 units, and then I have plotted the ABCD points, the roots Z1, Z2, Z3 and Z4, and then I have connected AB, BC, CD and DA, and I have got the A prime, B prime, C prime and D prime as the midpoints of these line segments. Okay, and now we have to get these are the solutions. So we have to first of all know the complex numbers represented by A prime, B prime, C prime and D prime. Okay, we know the complex numbers for A, B, C and D, but we do not know the complex numbers for A prime, B prime, C prime and D prime. So let us take at least one of them, because as I have said, if and they have said 4 of the roots. You see, this is important. 4 of the roots. That means P, P's value should be 4 or more than 4. Because if P is 3, W cube is it is a cubic equation, definitely you will not be having 4 roots. So P's value can be 4 or more than 4. Okay. And these are the 4 of the roots. So I can take any of them and substitute in this equation. Okay. So first of all, let me get the complex number which A prime is representing. Okay. You can take B prime, C prime or D prime, any of them. So what is A prime? You see, this is O, the origin. The triangle OAB, it is an isosceles triangle because this is 2 units. This is the radius of the circle, and this is also the radius of the same circle. So it is an isosceles triangle. The OAB triangle is an isosceles triangle. So and this is the 90-degree angle. Okay. So what will be the length of EB? EB square, I'm using the Pythagoras theorem, is equal to 2 square plus 2 square. 2 square is 4, 4 plus 4 is 8. Therefore, EB should be equal to square root of 8, which is equal to 2 root 2. Okay. And E dash or E prime is the midpoint of EB. So what will be EA dash or EA prime? It will be half of 2 root 2, which will be 2 root 2 units. Okay. So this is root 2 units and this is 2. Okay. And this is also a 90-degree. So I am trying to get the length of A dash, because in order to get the complex number represented by A prime, we need two things. We need the modulus, which will be the distance OA prime, and we need the argument, which will be this angle. Okay. And we know that this part is pi over 8. Okay. To that, if I add this portion, I'll be getting the argument. So these are the two things that I need. So first of all, let me get the modulus. I have to get the OA prime, this distance. Okay. And since OAB, the triangle OAB is an isosceles triangle, and I have joined the vertex to the midpoint of the base, therefore this angle has to be 90 degree. OA prime is perpendicular to AB. Okay, so this is a 90-degree angle. Therefore, I can use the Pythagorean theorem again to get the OA dash. So, OA prime square, I have represented it as x, or I can just write OA prime square plus root 2 square should be equal to OA square, which is 2 square. So, therefore, OA prime square is equal to 4 minus 2, because 2 square is 4 minus root 2 square is 2. So 4 minus 2, which is equal to 2. So therefore, OA prime is also having the magnitude of root 2 units. Okay. So this is also OA prime. This is also an isosceles triangle, right angled isosceles triangle. So OA prime is root 2 units. So I have got the modulus of the complex number. Now I have to get the argument. What is the argument? These two are two congruent triangles. OAA prime and OBA prime, these two are two congruent triangles, and this angle AOB, angle AOB is 90 degrees. So angle AOA prime has to be 45 degrees or pi over 4. Okay. And this part we know this is pi over 8. So this part is pi over 4. This part is pi over 4 and this part is pi over 8. So what will be the argument? Pi over 4 plus pi over 8 is equal to 2 pi over 8 plus pi over 8 is equal to 3 pi over 8. So this is the argument. This is the modulus. And this is the argument. Okay. So therefore, A prime is representing the complex number root 2 e to the power of I 3 pi over 8. Clear? And we are having the equation w to the power of p is equal to 2 to the power of q. Let me show you the equation once more. See, w to the power of p is equal to 2 to the power of q. We are asked to find the least possible value of p where p and q are positive integers. So, as I have done for the subpart D, I had taken one of the roots for this v to the power of 4 equal to a plus bi. I will be applying the same logic to solve this one also. I will be taking one of the roots that I have taken a prime in this case, which is representing this complex number root 2 e to the power of I 3 pi over 8, and I will be substituting this in place of w. Okay, so since a prime is a root of w to the power of p equal to 2 to the power of q, therefore root 2 e to the power of I 3 pi over 8 raised to the power of p should be equal to 2 to the power of q. Okay, so root 2 is 2 to the power of half. So therefore 2 to the power of half raised to the power of p times e to the power of I 3 pi over 8 raised to the power of p is equal to 2 to the power of q. Okay, and 2 to the power of q can be written as 2 to the power of q times 1. Why am I writing this times 1? Because I need some equivalent part over here also. I want to write e to the power of something. Okay, so that is why I have written 1. So I can write this as what is 1? I can write 1 as e to the power of I 0. I can write that because cos 0 will be equal to 1 and I sin 0 is 0. So 1 can be written as e to the power of I 0. Okay, so this I am writing. I do not know whether this will be correct, whether this will be solving my purpose, whether I'll be getting the answer in this way, but let me try. So this is I0. Okay, so now from here I am getting two equations. 2 to the power of this is p over 2. So therefore p over 2 should be equal to q. 2 to the power of p over 2, and over here on the right side it is 2 to the power of q. So equating these two, I am having this equation p over 2 equal to q, and I know p is an positive integer and q is also another positive integer, and I have to find the least value of p. So I may be tempted to write the value of p as 2 because 2 is a positive integer and 2 over 2 will be equal to 1. So q will also be another positive integer. But don't do that. You check both the equations. From this part, what am I having? I'm not taking the I. So it is 3p pi over 8 equal to 0. From this equation, are you getting a positive integer value of p? From this equation, you are getting the value of p as 0 because 3 is not equal to 0, pi over 8 is not equal to 0. But 3p pi over 8 equal to 0, therefore p has to be equal to 0. But p is a positive integer, so p cannot be equal to 0. If p is 0, q will also be equal to 0. So don't assume that the p's value will be equal to 2. If you put 2 over here, this equation doesn't get satisfied because 3 times 2 will be 6. 6 times pi over 8 definitely not equal to 0. So p's value is definitely not equal to 2. So let us just forget about this equation. Let us focus on this part. E to the power of I 3p pi over 8 equal to e to the power of I. This time I have taken 0. Now I will not be taking 0 because I have seen that if I take this as 0, it doesn't work. I have to write 1. What can be the other angle? I know cos 2 pi equal to 1. So I can write this as 2 pi. So therefore 3p pi over 8 should be equal to 2 pi. And this will be getting cancelled and we will be having p equal to 16 over 3. Cannot be taken because this is not an integer. So cannot be taken. So similarly, if I take this is giving us the p's value as 0. This cannot be taken, that cannot be taken. Now again, I'm writing the same equation. ei 3p pi over 8 equal to e to the power of I. Now again, cos 4 pi. See, I'm just getting the values of the angle for which cos of that angle will be equal to 1, because the sine part, the imaginary part should be equal to 0 and the real part should be giving me this one. Okay. So, therefore, e to the power of I, and this time I'm taking cos 4 pi. Let me see. So, this implies 3p pi over 8 equal to 4 pi. These two will be getting cancelled and you will be having p equal to 8 times 4 is 32. 32 over 3 cannot be taken. It is not an integer. Okay. So, now I am taking ei 3p pi over 8 equal to e to the power of I 6 pi. I'm just going on adding 2 pi's. So, cos 6 pi will also be equal to 1 and sin 6 pi is 0. So, therefore, 3p pi over 8 is equal to 6 pi. These two get cancelled and I have the p's value as 6 times 8 over 3. So now this cancels and I get the p's value as 16. This is the smallest value that p can have as a positive integer. Okay. And therefore, since p over 2 is equal to q, therefore 16 over 2 is equal to 8 equal to q. Okay. Therefore, q is equal to 8. So we have completed answering this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. It will be increasing my videos reach. It will be helping other students because other students will also be knowing about my video. You will not only be helping me, you will be helping other students as well. And we meet again very soon in our next session. We'll be starting to solve a new paper. Till then, bye.